Hello friends, I hope you are well at home and studying well. Today we will learn about graphical representation of motion. We will now discuss the various type of graphs which can be used to calculate speed, acceleration and distance traveled by a body. But first of all, a very important point to remember here is that in the drawing of graphs, the terms speed and velocity are used in same sense. In most of the graphs which I am going to discuss now, I will be using the term speed. At some of the places, however, the term velocity will also be used. This is because even in the examination papers, they use both the terms speed as well as velocity in the question based on graphs. We will first study the distance time graphs and then speed time graphs or velocity time graphs. Please note that in drawing graphs based on motion, time is always taken along the x-axis and distance or speed is taken along the y-axis because time is independent quantity. So without wasting of time, let's get started. Motion graphs are an important tool used to show the relationship between position, speed and time. It is an easy way to see how speed or position changes over time. These type of graphs are called kinematics graph. There are two types of graph. First is position versus time or distance versus time graph. Second is speed versus time graphs. Distance time graph represent the change in the position of an object with respect to time. Time is taken along x-axis and distance is taken along y-axis. In case of uniform speed, when a body moves with uniform speed, it will travel equal distances in equal intervals of time. In other words, the distance traveled is directly proportional to time. We can now say that the distance time graph of a body moving at a uniform speed is always a straight line. The straight line is known as a slope of curve. And the slope of a distance time graph indicates speed of the body. So the distance time graph of a body can be used to calculate the speed of the body. Suppose an object moves from A to B and it covers a distance s1 and s2 with respect to time t1 and t2 respectively. Then the slope of the curve speed is equal to s2 minus s1 divided by t2 minus t1. Basically, slope is nothing but just a ratio of y-axis divided by x-axis. In other words, the slope of a distance time graph indicates speed. Hence, we can use a distance time graph of a body to find the value of speed of the body. Next is non-uniform speed. We have seen above that if the speed of a body is uniform, then its distance time graph is a straight line. If, however, the speed of a body is non-uniform, then the graph between distance traveled and time is a curved line. Let us take an example. Suppose you are helping a friend who is training for a track meet. She wants to know if she is running at constant speed. You mark the track in 50-meter increments and measure her time at each position during a practice run. Create a position time graph using her data. For position time graph, we will take a graph paper and plot the above given time values on the x-axis and corresponding distance values are plotted on the y-axis. When you have plotted all 4 points, you should get a straight line graph. Next question is, what would her speed be? For speed, we will choose any point of distance and divide it by time. Suppose we take second point when time is 10 seconds and position is 50 meter. Speed is equal to distance upon time. That means 50 meter divided by 10 seconds is equal to 5 meter per second. For every distance, we can see speed is constant. Next, slope is the ratio of rise y-axis to the run x-axis of line on a graph. A bigger slope means a steeper line, which means a faster speed. In this example, we can see that red car moving fastly and blue car moves slowly. In a distance time graph of a body, a straight line sloping downwards indicates negative slope or decelerating. In this given figure, the first graph is slowly decelerating while the graph second is quickly decelerating.